We live in an age where voices lie, where faces can be fabricated, where intent can be simulated, where I promise is no longer evidence. For most of human history, trust was a social act. A handshake, a reputation, a shared story. But today, trust is no longer just relational, it is computational. Structural, mathematical. Tonight, I want to take you on a journey, from psychology to game theory to cybersecurity to artificial intelligence, from handshakes to formulas. And by the end, I want to ask you something uncomfortable, or systems that eliminate the need for it. In 1967, psychologist Julian Rotter defined trust as an expectancy, a belief that another's word or promise can be relied upon. Trust was psychological. It was subjective, it was about character. Then came game theory. The prisoner's dilemma taught us something profound. Cooperation is fragile. If both parties cooperate, both benefit. If one defects, the other suffers. Trust is always exposed to betrayal. Trust, therefore, involves risk. In 1979, sociologist Niklas Luhmann made an important distinction. He separated trust from confidence. Confidence requires no risk. Trust does. Trust is stepping across a bridge you cannot fully inspect. Already, something mathematical was emerging. Trust was no longer mystical. It was probabilistic. It was risk-weighted decision-making. In 1994, Stephen Paul Marsh published a doctoral thesis that did something revolutionary. He formalized trust as a computational concept. He proposed that trust could be expressed as a function, the trust that agent X has in agent Y in situation alpha equals. Multiplied by the historical trust disposition, trust became numeric, not moral, not emotional, numeric. A value that can increase or decrease based on evidence. This was the bridge between social science and machine systems. Trust became something that could be updated, weighted, modeled. It became measurable. Through the 1990s and early 2000s, network security followed a simple assumption. Inside the firewall equals trusted, outside equals untrusted. Security expert Bill Chesick famously described this as a hard, crunchy shell with a soft, chewy center. Once you were inside, the system assumed you meant no harm. Intent was the assumption. Then breaches exploded. Insiders caused damage. Compromised credentials bypassed perimeters. Trust became the vulnerability. John Kindervag Forrester reframed the entire paradigm around 2009. Zero trust, never trust, always verify. Not because people are evil, but because intent cannot be measured reliably. Zero trust is not cynicism, it is structural realism. It removes the assumption that good intent equals safety. It says trust is not a feeling, it is a system property. Now let's move from enterprises to families. The FBI recently advised families to create safe words. Why? Because AI voice cloning allows criminals to simulate your child's voice. Imagine receiving a panicked call. Dad, I'm in trouble. The voice sounds right, the emotion sounds right. But a safe word disrupts the illusion. Only someone with prior shared knowledge can answer. This is not new. It is pre-shared key authentication. In cryptography, two parties share a secret key K. To prove identity, the caller must demonstrate knowledge of K if received phrase equals expected phrase, then trust equals 1. Otherwise, trust equals 0. That is a mathematical decision boundary. A safe word is a human-readable authentication protocol. It converts trust from intuition into verification. At its core, authentication is math. Probability of guessing a safe word randomly equals 1 divided by the size of the possible phrase space. The longer and more unpredictable the phrase, the lower the probability of compromise. This is entropy. Security is not about good intentions. It is about reducing attack probability below acceptable thresholds. Safe words reduce impersonation probability. Zero trust reduces implicit access probability. Marsh's equation models relational trust. Game theory models strategic trust. Cryptography models computational trust. All roads converge, a function of evidence, a function of entropy. A function of verification cost. Part VI, the AI era and the crisis of authenticity. Artificial intelligence changes the equation again. We are entering an era where surface cues are unreliable. Your eyes can be deceived. Your ears can be deceived. Your intuition can be deceived. Intent cannot be inferred from presentation. If intent is unverifiable, what replaces it? Structure. Verification, architecture. This is why zero trust is not just an IT concept, it is a civilizational pattern. We are redesigning trust from social assumption to structural guarantee. But here is the uncomfortable part. What happens to society? Trust lubricates cooperation. If every interaction requires verification, friction increases, but less human. Do we create a world where nothing is assumed, everything is challenged, and spontaneity dies? Or do we create a world where structural verification actually frees us, because we no longer rely on gut feeling, we rely on design? Safe words protect families. Zero trust protects enterprises. Mathematical trust models protect distributed AI systems. But what protects society? Will they trust each other using formulas we designed, or will they learn emergent trust strategies beyond human intuition? Are we building AI that operates under Marsh-style probabilistic trust, or are we building AI that exploits our remaining human assumptions? For centuries, trust was relational. In the 20th century, it became theoretical. In the 21st century, it became computational. Today, it is architectural. The shift is profound. Do we still need character? What happens to virtue? Have we gained security or lost innocence? Should humans still do so? Who engineers the engineers? Thank you.